Very interesting, though. Very interesting little drink. And they get more interesting the more you have. But I did discover that Polish vodka is my new best friend. I woke up this morning and I just, if I drink that much back in the States, if I drink vodka or something, it just, I remember sitting in a booth last night, and then the next thing I remember, I woke up in my hotel room. Now, if I drink that much back in the States, when I wake up, it's just really, really bad. I woke up this morning, I just kind of turned over, and I looked, and I saw it was 11 o'clock in the morning, which is really good I didn't have a morning session today, because I really would have missed. I felt great. I felt so great, I'm going to do it again. So I'm really looking forward to the after drinking event after this. Distributed messaging is something that is rather complex. The systems around distributed messaging are complex. They wanted me to keep this talk, somewhere around level 100, 200. So we're going to be talking about distributed messaging systems, and look at some code on how to implement some of the simpler things. We're not going to get into really complex scenarios, but there's several code examples and demonstrations to show. Distributed messaging systems, like I said, they get really, really huge and extremely complex. I'm working on one right now. I was consulted, until about 6 months ago, and I got hired by a company that is going to rewrite their ERP, which currently resides on an AS400, and it's a manufacturing company, so they have manufacturing systems, accounting, order placement, purchase orders, inventory, warehouse management. And I went in, and they had started on the code, and they had a website. And they said, yeah, we're going to replace that in about 2 years. Well, after I explained to them, what an enterprise ERP system is and how it operates and all the communication patterns, now they don't have a website, haven't gotten that far yet, but they have 37 projects, and it's going to take about 8 to 10 years to do. So distributed messaging systems are very large. We use distributed messaging systems in the enterprise. The biggest reason is scalability, and distributed messaging is SOA. Scalability and the robustness of doing transactional, reliable messaging in an SOA environment. And it scales very, very, very well, especially when you start talking about pub-sub scenarios, publishers and subscribers, which we'll talk about a little bit. It leverages all your existing assets. A lot of companies, you see EAI and ETL. EAI is Enterprise Application Integration. ETL is Extract, Transform, Load. ETL is what most people are familiar with. When they migrate systems, I got to take this out, or I'm just going to sit here and play with it the whole time. ETL is what you're familiar with when you extract data from an existing system, transform that data to suit your purposes, and load it into a new system. And a lot of that happens, and it's data duplication. They're using stuff like, I forget what it's called now. It used to be DTS in SQL Server. Now it's, I don't know what it's, SSIS, yes. Right now, a lot of places use SSIS to extract data from one system and copy it and put it into this system. EAI eliminates that because we allow systems to remain autonomous and leverage their existing data without having to move that data. We move messages that describe the behaviors of that system and describe the data within that system. So the service, all services are autonomous. Services, we're going to talk about service boundaries a little bit. But services are nothing more than a boundary around, typically centered around aggregate routes. A lot of services are centered around a single aggregate route. Like an order, when you place an order is an aggregate route. And you can have a single system that surrounds just the fact that you have orders. Same thing with inventory item. An inventory item is typically an aggregate route. And you have an entire system around the concept of inventory. And they sit and they run on their own. It's all the code that's within that service is about that service. And it's independent of anything else that exists within the enterprise. And we use messaging to communicate between these systems. We're like almost halfway done with the slides. I hate slides, but they wanted me to have some slides. So messages, again, this is the way that we communicate with services. And messages are the only way to get in and out of a service, across a service boundary. And there's multiple types of messages. You can have multiple aggregates within a service boundary, but we still use messages to communicate between those aggregates, because aggregates are still a boundary. Everybody understand aggregates? When I say aggregates? That typically, when you're within a service boundary, it's not distributed messaging, but you're still using messages to communicate between aggregates, and you can do stuff like that with like an in-memory distributor. What we're going to be looking at today is in-service bus. We're going to look at, there's 3 service bus implementations out there that are open source for .NET. No. Well, should have just put them in here. One of them is the one we're going to look at, which is in-service bus. The other one is mass transit. Both of them are open source. And then Allende, Oren Eine, wrote one that's part of Rhino. So there's a Rhino service bus as well. And when you're crossing service boundaries, that's where the bus comes into play that we're going to be looking at today. Within service boundaries, you can use something that's in memory. You can even use something like WCF. The message contracts are very, very, very key to communication between systems. The contracts define the data and they define the behavior that exists within a service. So the anatomy of a message. Messages can be very, very, very large, unfortunately. You see the last 2 bullet points up here. Immutability is nice. The reason that we like immutability is because if you create a message and you dispatch that message and it's picked up by a consumer, you want to ensure that that message can't be changed by the consumer. That the message that it's going to deal with is the same message that you sent. And that's why we like immutability in our messages, so that they can't be changed by somebody else. Now that causes a little bit of a problem, and there's some tricks that you have to get around because of serialization. Serialization likes property getters and setters, and that kind of screws up, your ability to do immutability. But there are ways, like I've seen implementations like in the setter on a message, you may set a flag that says this has been set, and then if anybody tries to set it again, the flag says it's already been set once, you can't set it anymore. That's how some people get around serialization issues with immutability. So the deserializer is the only person or the only object that's allowed to actually set anything on the message. And it's going to deserialize what you serialize it to, so it can't be changed. Fluent builders are very nice as well. But again, fluent builders can get really, really, really ugly with really large messages. Here's an example of building a message with a fluent builder. Now you can imagine that, a very large order, if somebody's been around shopping on your site, and they've got credit card information, billing address, shipping address, all the stuff that they ordered, you can see that these things can get extremely large. This is very small, this message that we have here. But they can be very big. and the builders behind your ability to